Hi there, and welcome back to this video series on the CCNA security exam, implementing Cisco iOS network security. This is the first video in section 7, which deals with Cisco firewall technologies. In this video, we'll look at an introduction to firewalls. We'll also look at the different types of firewall technologies, their strengths and their weaknesses. You'll notice that we're back to our former lab setup. On one end, organizations want to make their networks available. For example, they want to have an online presence. On the other end, they want to make their networks as secure as possible from unauthorized access. So we could have something like this, and this is security, and this is availability. Now the whole concept is to gain a balance between security and availability. So if you are going to be available, you are going to be not so secure, and if you are going to be secure, you are going to be not so available. So the point is creating a balance between availability and security, maybe somewhere at this point. So the extreme form of availability is when there's no form of security at all. So you just have an open access to the entire public. On the other hand, an extreme form of security would be like a complete lockdown where nobody has access to your resources. But thankfully, we have these things called firewalls that help us create a balance between availability and security. Let me clear this screen. So normally you have your organization. Let's just draw this as an organization. And you also have, for example, the internet. That's like the public network. So internet. Now the point is to connect your organization to the internet. But just allowing this connection means that it's the open access, which allows everybody access to all your resources, which is basically no security. But with firewalls, you can place a firewall here that is going to control access between the different domains. So for example, this is your trusted domain, your internal network is your trusted domain, and this is your untrusted domain. And that is what a firewall does. A firewall basically provides access control between security domains. So for example, between the trusted and the untrusted. Now, of course, usually you're going to have allow access from the trusted to the untrusted. This is going to be allowed, but access from the untrusted to the trusted will be denied. This is what firewalls, this is the basic concept of firewalls. They provide access control between security domains. From this, it is immediately evident what the features of a good firewall are. So features of a good firewall or features of a good firewall deployment. Let me just clear the screen up a little bit. The first thing is the firewall must be the only point of access into that network. So for example, if you have another link going to the internet, then this is not a good firewall deployment, because an attacker can effectively use the path of least resistance to get to your network, and then your firewall will not be the only thing on the paths to get to your network. So that's one. So the second one is that the firewall itself must be hardened. So it must be hardened to security attacks. That means, for example, a denial of service should not be able to bring down this firewall. There are different types of firewall technologies, including the stateless. So this is the oldest one. The stateless packet filtering. We also have the proxy servers, also called the ALG. That's application layer gateway. We also have the stateful packet filtering. So that's stateful. The first one is stateless, while the other one is stateful packet filtering. And we also have, so the fourth one is going to be application inspection. We're going to look at these firewalls in details, one after the other, and we'll look at the benefits and advantages and disadvantages of each one of them. The first firewall technology that we're going to talk about is the stateless packet filtering. It's basically the oldest. It's the oldest type of firewall technology, and it makes decisions based on the layer 3. That's things like IP address. So you have like IP address, and layer 4. So layer 4 would be things like TCP port numbers, for example. We have already seen an example of this with the ACLs when we configured access control list on the routers. Now you should understand that stateless, as the name says, does not keep track of state. So what does this mean? Let's take an example. If you have a firewall and you have this user going to this user, so let's say this is inside and this user is on the outside. Now if, for example, this inside user opens a connection to the outside user, now remember that a connection will be made up of several packets. Now with the stateless packet filtering, since it does not keep state, even if these packets are of the same connection, it treats them as individuals, so it treats them independently. Therefore, it's not able to determine that a packet is part of an existing flow or is part of a new flow. Now let's talk about the strengths and weakness of this. I'm just going to clear up this screen. Now one of the strengths, so I'll just write strengths here. One of the strengths is that it is very simple to implement. As we saw with ACLs, you can easily write permit and deny statements. Another thing is that it has low processing impact. As we saw, we implemented it on routers and you can even implement it on switches. And finally, it is cost efficient. So you do not need a particular dedicated hardware appliance. Like we saw, you can also implement it on routers or something. Now let's talk about the weaknesses. Now, of course, the first weakness that we have is that it is stateless, meaning that it's not intelligent. It's not able to determine that a packet is part of an existing flow or is part of a new flow. Another weakness is that it is susceptible to IP spoofing attacks. So we know that even though this stateless packet filtering gives us basic packet filtering capabilities, which is nice because it's not so processor intensive, we cannot really use this firewall technology because it doesn't meet the needs of today's demands. The next one that we're going to consider are the proxy servers, also called the application layer gateway, ALG. Let's take, for example, we have this firewall. It's a proxy server. So proxy server, and then you have like a server on the outside and you have a client here. Now with the proxy server, connection is not actually made from the end user. So let's just call this the end user to the server. This is how the connection flows. The end user opens a connection to the end server, which is intercepted by the proxy server. And the proxy server opens a connection to the server. Now the server thinks it's talking to the proxy server, so the reply is made to the proxy server, and then the proxy server replies to the end user. So in this way, the end user is kind of protected. So you have some level of protection when you're using the proxy server. The proxy server can operate between layers 3 and 7. And because of this, so because it gets up to the application layer, it can be very, very granular. So let's talk about the strengths and the weaknesses. So here we'll talk about strength. Like I mentioned before, the first strength is that because it can get up to layer 7, it is very granular. Also, with proxy server, you can have very, very detailed logging. So it can tell you that this user tried to get to this particular server and this particular request was denied and things like that. And like I mentioned, you have protection for your end users because the connection is not actually between the end users and the servers. It's actually between the proxy server and whatever server they are trying to connect to. Now we can talk about the weaknesses. And the first one is that the proxy server is software based. And since it's software based, it is very processor intensive. Software based, so it's processor intensive. Now the second thing, or the second weakness that we can have, is that you may require a special client to be used on your end users. Special client may be required. And lastly, the third weakness that we may have is that not all applications may be supported. Now this is because the proxy server needs to know how to deal with different apps. So not all applications may be supported. This is the third type of firewall technology that we could talk about. That's the stateful packet filtering. So it's just like the packet filtering, like this, but then it's stateful. Now what does stateful mean? Also, you should keep in mind that this is one of the most used firewall technologies. So stateful means that it can determine if a packet is part of a new connection or part of an existing connection. Now, why is this important? I'll show you with a diagram. So if you have a firewall like this, and you had these internal users, and you had these external users. Now let's say on this edge of the firewall there's a deny all. It means that everybody from here cannot, so let's say this is the outside and this is the inside. So what it means that everybody from the outside cannot go to the inside. That's denied. Now when the inside tries to connect to the outside and this outside user tries to reply, by default, because of this deny, the packet is going to be dropped. But with the stateful packet filtering, it's able to automatically permit return traffic. That's because it keeps track of the state. So it keeps information like the source and destination ports and IP address and other information about the packet in a state table. So this is the state table that it uses. So for example, we could have something like source IP address, destination IP address, source port, destination port, and then you can have some other information like that. Now let's talk about the strengths and weaknesses of this firewall technology. So strengths, and the first strength is that the state table provides intelligence. So because of the state table, it is intelligent because it can determine if a packet is part of a new connection or part of an existing connection. Now it also provides protection against spoofing and denial of service. And this is still because of the state table that it keeps. Spoofing and denial of service attacks. Another advantage is that it can be used as a first line of defense, and it is actually being used as a first line of defense in several organizations. Now we can talk about the weaknesses, and one of the weaknesses is inherent in the packet filtering. The fact that it operates in layer 3 and layer 4. That means it may not be able to protect against application layer attacks. So that's because it does not go all the way to layer 7. Another weakness is that not all protocols are stateful. So you have protocols like ICMP and UDP. So for example, you have ICMP, which is not stateful, and then you have UDP. A third weakness is that it cannot provide user authentication. But like I said before, the stateful packet filtering is one of the most used firewall technologies. As we'll see, it can also be used with the application inspection. The final firewall technology that we're going to talk about is the application inspection. Stateful packet filtering firewalls can implement application inspections so as to see into the application layer information. Now these are similar to proxy servers because they operate at layer 7, thus they can see into layer 7, but unlike the proxy servers, they do not initiate and terminate connections for users. Application layer inspection is also called deep packet inspection. So when you hear deep packet inspection on the ASA or something, just know it's also referring to application inspection. That's DPI. One of the weaknesses of the application inspection is that it requires greater processing power. Now we have seen the 4 different types of firewall technologies, and the Cisco firewalls that we're going to be looking at in this CNA series. That's the Cisco iOS firewall and the Cisco ASA. That's the Cisco ASA. ASA stands for Adaptive Security Appliance. Now these firewalls implement packet filtering. That's the static packet filtering, like stateless packet filtering, so they can use ACLs. They also implement the stateful packet filtering. And finally, they can implement the application inspection. So of the 4, they don't implement proxy servers. This brings us to the end of this video, where we have looked at an introduction to firewalls, and we have taken a look at the different firewall technologies that we have, including their strengths and their weaknesses. I hope you have found this video informative, and I'd like to thank you for watching.